We're going to have a quick look at right angle triangles and when we use Pythagoras, when we use Sohcahtoa trigonometry. So here are two right angle triangles. We know that they're right angle triangles because they both have a right angle there. Now the difference between these triangles is that in this one we have 3 lengths in use. I've been given 2 and asked to find the third. For this one, I'm being asked to find a length. However, I've only been given 1 length and I've been given an additional angle. So when you get right angle triangles, it's important to identify whether you're going to use Pythagoras or whether you're going to use trig. Now, in this case, I know this one's Pythagoras because in order to use Pythagoras, you need to ask yourself, is it a right angle triangle? Yes. Does it have 3 sides being used? And in this case, used means you're either given it or you're asked to find it. And yes, this one does. So that tells me I can use Pythagoras. If I don't have 3 sides used, then I need to consider my checklist for trig. Is it a right angle triangle? In this case, yes it is. In order to use trig, I need 2 sides to be in use and I need 1 extra angle. And again, that just needs to be used. You don't need to be given it. So in this case, yes, there's 1 side missing and I'm given another, so 2 sides are in use. And yes, I have an angle other than the right angle. So ever so quickly, let's have a look what Pythag tells us. Pythagoras says that the length of the longest side squared is equal to the sum of the 2 shorter sides squared. So in this case, I identify the long side, which is there, x. So x squared is equal to the 2 shorter sides squared and added together, 7 squared plus 8 squared. In my calculator then, I'll write then x squared and I'll put into my calculator 7 squared plus 8 squared equals 113. So I'm just going to write that there, 113. Now I don't want x squared, I just want to know what x is. So x is going to equal the square root of 113. Now there's 113 still on my display. I'm going to press square root and then I'm going to press the button called ants and that'll bring your last answer up. So I want to find the square root of my last answer equals root of 113. Press SD and that tells me it's 10.630. So x equals 10.630 and so on. And whatever measure of accuracy they want that rounded to, you would need to round that then. Not forgetting that this is in centimetres because all the other lengths are in centimetres. It's worth checking with Pythagoras if you found the longest side, so in this case this is the longest side, then you need to make sure that the number that you've got, in my case 10.63, is actually longer than both other sides. In this case, yes it would be. Now for trig, it's a little more complicated. However, I was quite flippant over here in making the statement that this is the longest side. Well, how did I know this was the longest side? Because it's not necessarily always the slopey one. The triangle might be upside down and this might be flat on the ground. In order to identify which is the longest side, you go to the right angle and you see what's directly opposite it. That's the longest side and it has a name. It's the hypotenuse of a triangle. And the hypotenuse is always the longest side of any right angle triangle. So let's say I've done my triangle checklist and I've identified I can't use Pythagoras for a question, just like over here. What I need to do is label my triangle up. I always start with the right angle and I go opposite, and I know that that side is called the hypotenuse. Then I go to my additional angle, which in this case is 29. Opposite that additional angle, I have my opposite length. And then the one that's left over, which runs alongside both the right angle and the additional angle, is called the adjacent. It runs next to both angles, that's the adjacent. So that's the first thing I need to do. Now, the reason I do this is because I'm going to need to use Sohcahtoa in order to solve this and identify a trig ratio to use. The Sohcahtoa isn't given to you in the formula booklet unless you're doing an IGCSE, in which case it is. So we're going to need to remember Sohcahtoa. And what this means is that the sine of 29 is equal to the opposite over the hypotenuse, cos 29, adjacent over hypotenuse, tan 29, opposite over adjacent. These are our trig functions, our trig ratios. So let's have a look at what we've got in the question. I'm looking for the hypotenuse, so the hypotenuse is in use. I can go ahead and cross out anywhere there's a h. The adjacent, I don't have anything for that. I'm not using it. The opposite, I've been given that, so I am using it, so I can cross out my O's. Now, when you've done that, you will realise that there's only one of them that has both sides crossed out. That is the trig ratio we use. So in this case, it's sine of theta equals the opposite over the hypotenuse. And all this sine means is whatever your angle is. So sine doesn't really exist as a word by itself. It has to be attached to an angle. In this case, it's sine of 29. And I'm replacing theta with 29. Substitution, essentially. So I'm putting it in a bracket. Sine 29. And that's equal to the opposite, which is 7, over the hypotenuse, which is x. Now, that's all well and good, but I want to know what x is. At the moment, it's trapped at the bottom of this quotient. I need to get x on its own. I need to make x the subject. If you struggle to rearrange algebra, then this is going to be an issue for you. A lot of people learn that you can just swap them, but the reason for that is to get rid of that divide by x, I would have to multiply by x on both sides, and then to get rid of the sine 29, I would divide that on both sides, which would mean I'd end up with x equals 7 over sine 29. I can then put that in my calculator. 7, or the quotient button, 7, press down to get underneath, sine 29. I'm not going to forget to close my bracket off using the bracket button. And then I'm going to press equals, and that's 14.438. So x equals 14.438. And that goes on to whatever degree of accuracy that you want. So that's just a quick run through of finding a length using trig, and I only did it really so you can look at the labelling of the angles. Now let's have a little look briefly, because I kind of skimmed over what Sohcahtoa actually does, or what it actually means. So when you've done your eliminating and you're selecting one of these ratios, the ratios are, for this one, sine of your additional angle equals the opposite over the hypotenuse. So it literally tells you what function you need to use to get the answer. Here it's cos of the angle equals the adjacent over the hypotenuse. And this one is tan theta equals the opposite over the adjacent. That's what they mean. If you've got the opposite and the hypotenuse in use, you use sine. If you've got the adjacent and the hypotenuse, you use cos. Opposite and adjacent is tan. Now, I'm just going to give you an example of using trig when you need to find an angle, because it's slightly different to finding one of the sides. So I'm just going to roughly draw a right angle triangle there. Here's my right angle. This is what I'm going to want to find. And let's say I know that that is 5 meters. And let's say that this is 12 meters. I want to know what that missing angle is. So, quick trig checklist. Is it a right angle triangle? Yes. Have I got 3 sides in use? No. So that takes Pythagoras out of the question. Have I got 2 sides in use plus an angle? Yes, I have. So that tells me I need to use trig. That tells me Sohcahtoa is going to be important here. Now I need to label my triangle up. I always start with the right angle because opposite the right angle is my hype, and that's my longest side. Then I go to my theta angle. Opposite that I have the opposite, and then the one that runs alongside both angles is the adjacent. I've made a bit of a rookie error here. I've given you pretty much an identical triangle to the one I did above. Please be aware that this might be turned around, in which case that's, sorry about the bell, in which case they wouldn't always be in this order. You do literally need to go to the right angle and go opposite it for the hypotenuse. Opposite theta is opposite, alongside the 2 is adjacent. So let's have a look. What's in use? Alright, sorry about that. Clearly in demand. So I've labelled my triangle up. I need to decide which trig ratio I'm going to use now. So I'm not using my opposite. There's nothing there for that. I don't need to find it, and I've not been given it. I am using my hypotenuse, so I can cross out any of the h's. I am using the adjacent, so I can cross off any a's. And then that shows that the ka is the one with the 2 ticked off. So I know that I'm going to need to use cos of theta is the adjacent over the hypotenuse. So I'm going to substitute my values in now. Cos of theta, now the angle, well, it's x, so it's cos of x equals the adjacent, which is 5, over the hypotenuse, which is 12. Now, this is all well and good. I've got cos of x equals 5 over 12. I could put that in the calculator now, but I'm not going to. I'm going to wait until the end. I want x on its own. At the moment, x is attached to this cos. Now, you may be looking at this and thinking, well, in order to get rid of the cos, I can just divide cos away on both sides, because that would just leave me with x. But that's not what's going on here. This isn't cos times x, it's cos of x. And because cos is a function, you have to do the inverse of that function. And that is cos to the power of -1. And that's what you have to do to both sides. So cos to the power of -1 and cos to the power of -1. Now what you end up with here is cos cancelling down, leaving you with x equals cos to the -1 of 5 over 12. Now, how do you put this in your calculator? Well, let's have a look first of all at the whole cos -1 thing. I can see there's sine, cos and tan. And I'm going to be using cos. And if you look just above cos in the yellow writing, it's cos to the -1. Now, interestingly, to get cos to the -1, I must press shift and then cos. And if you can't remember it's cos to the -1, then when you're at this stage and you know you want to get rid of the cos, just think that you need to shift cos. You need to shift cos away. So you press shift and cos. So on your calculator display, you'll have cos to the -1 open bracket. I'm going to press the quotient button and I'm going to do 5 over 12. I need to close the bracket off, but if I press the bracket button as it is, then the bracket's just closed off down here. That doesn't look like what I want. So I'm going to have to press a cross out of my quotient and then close the bracket off. Then I press equal, and that gives me 65.375, blah, blah, blah. So x equals 65.375, and so on. In an exam, they will tell you a degree of accuracy to which that needs to be rounded. Right, so very quickly, here's a right angle triangle. I don't know yet whether it's Pythagoras or trig. I'm going to run through my checklist. This is a right angle triangle. Brilliant, I can see that from the little square there. Calculate the length of xz. xz. Alright, so that's what I need to find. I'm going to call it x. Give your answer correct to 3 significant figures. Okay, so it's a right angle triangle. There's no angle other than the right angle, so that tells me actually it's not going to be trig, but there's 1, 2, 3 sides in use here, so it's going to be Pythag. Now this is the right angle, and directly opposite the right angle we always have our longest side. So I know this is the longest side, and therefore Pythagoras says that x squared is going to be equal to this side, and it doesn't matter which order they're in, plus 3.25 squared. So the sum of those two sides squared. That then tells me that x squared is equal to 12.385. That means x has to be the root of 12.385, and therefore x equals 3.52. But I've taken that off the mark scheme. Let's see what the calculator says, because there's going to be rounding issues to deal with here. So root of 12.385 equals... Okay, so it would actually give you on the calculator 3.5192, blah, blah, blah. So there's a long number there. They wanted it to 3 significant figures. First, second, third, cut off after the 1. I have to pay respect to the fact that the 9 did exist, and therefore it makes that 1 round up. So that's 3.52, and that's where the answer comes from. This question is hidden Pythagoras, really. ABCD is a trapezium, AD is 10, AB is 9, DC is 3, angle ABC. Now, if you don't know how that works, the capital letters are always vertices, they're always corners. So angle ABC would be found by starting at A, going to B, and then ending up at C, and it's whatever angle gets enclosed. So ABC is this angle here, and that's 90 degrees. And it's also equal to angle BCD. That's also 90 degrees. Okay? We need to calculate the length of AC, giving your answer correct to 3 significant figures. Well, this is A and this is C. So what they're actually asking us to calculate in this question, I'll draw on in a blue dotted line, is that A to C. So that's the ultimate end. That's what I need to find. I'm going to call that X. Now, there's no easy way of getting this length AC, from what we already have. We've got a trapezium, and I know that that's 9, and I know that that's 3. I need to know what this is, because hopefully you can see this would be a right angle triangle with A, B, C. That's a right angle triangle there. So it would be really nice if I knew this length, because then I could square and add to get that. So in order to get that length, I'm going to take this right angle triangle here. I'll draw it in green. Now if I take that right angle triangle, I can use it to find the width of this trapezium, this base here. I know this is 9, I know that's 3, therefore 9 take away 3 tells me that this part is 6 centimetres. And I know that this here is 10, and assuming I've used a ruler and I wasn't so scruffy, that would be a right angle. Now, as we learned previously, directly opposite the right angle, we have our longest side. That's our hypotenuse, and it's the longest. And in the previous examples we've found the longest by squaring these two sides and adding them together, and then finding the root. However, this time, I'm not finding the longest side. I'm finding this, which we'll call A. Now, in order to find A, and I'm going to write it here, A squared is equal to, if it was these two added together would give you the longest side, then in order to find one of these two, I would just subtract them from what I know to be the longest side. So A squared equals 10 squared. Subtract 6 squared. So that means A squared equals 64. I don't want A squared, I just want A. So that's the root of 64. So A equals 8 centimeters. And that's what this length is here, 8 centimeters. Now, hopefully you'd be aware that the width here of 8 centimeters is the same as line BC. So I'm going to write here, I found that that's 8 centimeters. Now, because I know that that's 8 centimeters, use it to address the original question, which was find the length of AC, which I did in a blue dotted line. So if I make this triangle stand out a little more, hopefully I can see now I've got a new right angle triangle with a base of 8, a height of 9, because it was the whole original height, and I want to find the hypotenuse. I know it's the hypotenuse because it's directly opposite the right angle. If this is just looking a bit too confusing, I'm going to do a little sketch down here. So that's the right angle triangle I end up with. That's B, that's C, that's A. BC, I said, was 8 centimeters. BA is 9 centimeters. And AC is X. So now I can just use Pythagoras to find the longest side, which is the X. So X squared equals 9 squared plus 8 squared. So X squared equals 81 plus 64, which is 145. But I don't want X squared, I just want X, so I need to find the root of 145. And that's going to give me 12.04159. And that number goes on. It says they want it to 3 significant figures. So there's 1, 2, 3. Cut off there. Remember, a 0 is significant if it's after some other numbers. I have to pay respect to the fact it was followed by a 4, but the 4 doesn't have any effect. So X is equal to 12.0. Again, is the 0.0 necessary? Not particularly, but they wanted it to 3 significant figures, so I am giving them 3 figures. It is worth noting that you have found a length, so centimeters is also appropriate to put on the end. Here's a question which is a 5-mark problem solving one, and you actually need to use Pythagoras as part of the working out to get to the answer. I'm not going to go through it in depth. Press pause, have a go. I'll put a snapshot of the answers up. Okay, so ultimately this question is asking, if the farmer's only got 50 metres of fence, does he have enough? It's a perimeter question, you need to add up all the edges, but of course they haven't given you this edge. They expect you to know that you split this in order to get a right angle triangle here. And if that's 18 and that's 11, that means that this part here has to be 7 meters. So I need to use that information to find X. And to do that, I need to say that X squared is equal to 7 squared plus 10 squared. So X squared equals 149. So X equals the root of 149. So X equals 12.2065 ... So I know that, and I'll round it to 12.2. That is 12.2 meters. Now I need to find the perimeter, and I do need to show that I'm finding the perimeter. So perimeter equals this 11 plus this 10 plus this 18 plus this 12.2. So the perimeter of the field is 12.2 plus 18, 10, 11 equals 51.2. The farmer had 50 meters of fence, and the perimeter of my field is 51.2 meters. Does he have enough? No. He needs an extra 1.2 meters. Okay, so he doesn't have enough. That was Pythagoras in a problem. Okay, question 5 is a two-parter, part A and part B. I can see there's a right angle triangle. I'm going to very quickly do my triangle checklist. Is it right angled? Yes. Are there 3 sides in use? Oh, hang on. Well, there's only 2 drawn on there. Let's have a look what the question wants. ABC is a right angle triangle. AC is 6. AB is 13. Work out the length of BC. All right, so this is what they want. They want the length of BC. And they want the answer to 3 significant figures. Now, in a right angle triangle, I know that the hypotenuse is always opposite the right angle, and that is the longest side. So I've been given the longest side. That means the side I have to find is one of the shorter 2. Therefore, that squared, take away that squared, is going to give me the square of BC. So A squared equals 13 squared, take away 6 squared. So A squared equals 13 squared minus 6 squared. That's 133. I don't want A squared though, I just want A, so that's the root of 133. So that would give me 11.532, and that continues. They wanted it to 3 significant figures, 1, 2, 3. Cut off after the 5. The 3 doesn't have an effect on the 5, so the answer is 11.5. Don't forget that we are working in centimetres. And in fact, they haven't got centimetres anywhere on the answer line, so you'd probably get an extra mark. Even if this was completely wrong, you'd get 1 mark for writing centimetres. Now, part B is another right angle triangle. Quick mental checklist. Well, there's 2 sides. They haven't drawn on whatever it is I need to find, so I can't tell yet whether it's Pythag or Trig. PQR is a right angle triangle. PR is 17, PQ 25. Work out the size of angle RPQ. Now remember how to identify these angles. You start at R, you go to P, you end up at Q. What's been enclosed? This angle here. And so I need to find that. I'm going to call it X. Give your answer to 1 decimal place. I'll deal with that in the end. All right, so I can see I've got 2 sides and an angle in use. So that's going to be trig. And just to remind myself, I'm going to write here Sohcahtoa. And then I'm going to label my triangle up. There's the right angle. Directly opposite is the hype. Here's my theta angle. Directly opposite there, I have the op. This is the one that runs alongside both of them. That's the adjacent. Again, it's unfortunate that the triangle is in the orientation so that they've ended up being ordered this way. It doesn't always work out like that. I'm not using the opposite because I've not been asked to find it and they've not given it to me. So adjacent I've been given, I can cross that out. I've been given the hypotenuse, I can cross that out. And the S, the C and the T refers to the angle. Obviously I've got that, otherwise I wouldn't be using Sohcahtoa. So that tells me cos of the theta angle is equal to the adjacent over the hypotenuse. So that means cos of x equals the adjacent, which is 17, over the hypotenuse, which is 25. Now, I need to get rid of cos. I need to shift cos, which would give me x equals cos to the minus 1 of 17 over 25. And just a reminder of how to enter that in your calculator. You press shift, you can't really see that, shift, cos, and I press the quotient key, and it's 17 over 25. Make sure I bring my bracket out of the quotient, and that equals 47.1563. So x equals 47.1563, and that goes on. What did they want it to? 1 decimal place. Well, there's the decimal point, so this is 1 decimal place. I need to cut my number off there. I need to pay respect to the fact that there is a 5 I'm cutting off, and that tells my 1 to round up. So x equals 47.2, and it's an angle, so that's in degrees. Here's a problem-solving question that requires trig. You need to find angle y, and the question is, the ladder is safe to use when angle y is about 75 degrees. Is this ladder, which is there, the 6 meters, is it safe to use? So essentially you're finding, does that come close to 75 degrees? Press pause. When you're ready for the answer, press play. Okay, so this trigonometry question, I know that because it's a right angle triangle. There's 2 sides in use and an additional angle in use. So without any delay, I'm going to write down Sohcahtoa, and then I'm going to label my triangle up. There's the right angle. Opposite that is my hypotenuse. There's my theta angle. Opposite that is my op. And then that's the side that runs alongside the theta angle and my right angle. So that's my adjacent. I can see I'm not using the opposite there. I am using the hypotenuse and I am using the adjacent. So I can cross off all the H's and A's, and that tells me that it's K I need to use, which is cos of theta equals adjacent over hypotenuse. Notice how I write this out every time. I do that just in case I've got my letters the wrong way round, and I'm telling the examiner then, I may not have remembered this correctly, but this is what I'm going to use for the question, and then you might get some method marks. So I'm going to substitute my values in now. Cos of y, because that's what the angle is, equals the adjacent, which was 2.25, over the hypotenuse, which is 6. I need y on its own, so I need to shift cos, and that then leaves me with y equals cos to the minus 1 of 2.25 over 6. That then tells me that y is equal to 67.975 ... They said that the ladder is safe to use when it's about 75 degrees. Well, that's only 67 degrees, so that's not close enough to 75. So we need to finish this question by saying, no, it's not safe because it's not near 75 degrees.